We're going to wrap up this section on derivative shortcuts talking about exponentials and logarithms. So we'll start off with, just like last time, the rules for taking the derivatives of exponentials and logarithms. And we're going to specifically focus on the base of e, because that's where we're going to find most of our applications in the social sciences, in business, and economics. So the two rules we need to know are that the derivative of e to the x is equal to e to the x. It's actually its own derivative. It's a unique function. It's the only function whose derivative is itself. The other derivative that you should know is the derivative of the natural log of x. The derivative of the natural log of x is going to simply be 1 over x. Then let's look at what that looks like with an example. Let's look at the function f of x equals 2x to the 5th minus 3 e to the x plus 4 natural log of x minus the square root of x to the 5th plus 7 over x to the 9th. We now have the skills to take the derivative of this complex-looking function quite quickly. First, let's take care of the square root and the fraction, rewriting them in polynomial form. So f of x is equal to 2x to the 5th minus 3 e to the x plus 4 natural log of x minus, that's a square root, so the index of 2 is going to become the denominator, making it x to the 5/2, plus, to bring the x to the 9th up, it's going to make it a negative exponent, so it's 7x to the negative 9th. Now we can go through and find the derivative of f of x, or f prime of x, using the derivative rules we've discovered in this section. When we've got x to a power, we bring the exponent out and subtract 1. So 2 times 5 is 10, x to the 4th. Minus 3 times e to the x is its own derivative, e to the x. Plus 4 times the natural log of x puts you over x when taking the derivative. Minus, bring the exponent out front and subtract 1. So we have 5/2 x to the 5/2 minus 2/2 is 3/2. And then bring the exponent out front and subtract 1. 7 times negative 9 is negative 63, x to the negative 10th. And that quickly, we've been able to find this complex-looking derivative by using our derivative shortcuts of this section. It's now your turn to practice working with these derivative shortcuts on the assignment.